so they all strike the same part of the interface of the picture tube at the same time. This concludes review number 5. At this time, you should stop the video and complete section E of your student workbook. In this portion of the video, we will first examine the high voltage section of the color television receiver. We will examine the high voltage rectifier stage, high voltage regulator stage, the high voltage hold-down circuit, and the focus rectifier stage. Then we will end this portion of the video with information about the low voltage power supply section. We will begin with the high voltage rectifier stage. The primary function of the high voltage rectifier stage is to rectify the high voltage AC signal being fed into it from the horizontal output amplifier stage into a high DC voltage. In some color receivers, this voltage may be as high as 35,000 volts. This high DC voltage is then fed into the second anode of the picture tube. The heart of the high voltage rectifier stage is basically nothing more than a special high voltage half-wave rectifier diode. The high voltage regulator circuit is used to assure that the second anode voltage remains constant under different brightness conditions. Notice that the high voltage regulator circuit uses a closed-loop system. It basically monitors the high voltage output of the horizontal output amplifier stage. If the voltage on the amplifier stage becomes too high, the high voltage regulator will cause it to reduce the magnitude of the voltage. Or, if the output of the amplifier is too low, it will cause the output of the amplifier to increase the magnitude of the signal. There are 4 common high voltage regulator configurations in use today. These are the shunt regulator, pulse regulator, closed-loop diode regulator, and the closed-loop voltage-dependent resistor regulator. The government issued a number of regulations designed to protect the public from excessive radiation being emitted from television picture tubes. This brought about the advent of the high voltage hold-down circuit. The primary function of this stage is to reduce the high voltage output in the event of a malfunction in the high voltage stages, which would result in the high voltage becoming excessive. The focus rectifier stage is generally found in the older television receivers. The output voltage from this stage was typically 20% of the second anode voltage value. If the magnitude of the second anode voltage was 20,000 volts, then the output voltage from the focus rectifier stage would have been approximately 4,000 volts. The primary function of this stage was to assure that the image being shown on the screen was clear and crisp. The low voltage power supply is responsible for supplying sufficient DC voltages at the proper amplitudes to the various stages located within the television receiver. This stage also supplies the energy required to drive the heating element located within the picture tube. This power supply has all the elements of a standard DC power supply. It will typically contain a transformer, rectifiers, filters, and regulator circuits. The demand for current from this stage will normally range from 400 to 1500 milliamps. The voltage levels being produced by this stage will range from a few volts to over 300 volts DC. We will now pause for a short review of the material just discussed. The primary function of the high voltage rectifier stage is to convert the high voltage AC signal from the horizontal output amplifier stage into a boosted DC potential. This DC voltage is then fed into the second anode of the picture tube.